When installing multiple current-carrying conductors in a raceway or cable, it's crucial to understand and apply conductor derating factors as outlined in the National Electrical Code, specifically Section 310.15 Con. This section addresses the adjustment factors for ambient temperature and the number of current-carrying conductors in a raceway or cable. In the situation described, where you have 24 hot conductors which are current-carrying and 8 neutral conductors and a 2-inch aluminum conduit, the derating requirements of NEC 310.15 Con come into play. The primary goal of derating is to ensure that the conductors do not overheat, which can damage the insulation and potentially lead to electrical failures or even fires. The ampacity of a conductor is the maximum current in amps that it can carry continuously under specific conditions of use without exceeding its temperature rating. This ampacity is based on the conductor's insulation type and the ambient temperature. When multiple current-carrying conductors are bundled together in a conduit, the heat generated by each conductor can raise the overall temperature within the conduit. This increased temperature reduces the ability of the conductors to dissipate heat, effectively lowering their ampacity. Table 310.15 Con provides adjustment factors based on the number of current-carrying conductors in a raceway, cable, or earth. These adjustment factors are expressed as percentages and are applied to the conductor's ampacity to determine the allowable ampacity under the specific conditions of installation. Now, let's address whether the neutral conductors count towards the total number of conductors for derating purposes. According to the NEC, neutral conductors are generally not counted as current-carrying conductors for derating purposes under certain conditions. This is because in a balanced three-phase system, the neutral conductor only carries the imbalance of current between the phases. If the phases are perfectly balanced, the neutral conductor would carry little to no current. However, there are exceptions to this rule. A neutral conductor must be counted as a current-carrying conductor under the following circumstances. Firstly, when the neutral conductor carries a significant amount of current due to nonlinear loads, such as those found in electronic equipment and LED lighting. These nonlinear loads generate harmonic currents, particularly third harmonic currents, which add arithmetically in the neutral conductor. This can cause the neutral conductor to carry more current than any of the phase conductors. Secondly, when a single-phase 2-wire circuit or a 3-wire circuit is run in the same raceway or cable, the neutral conductor is always counted as a current-carrying conductor. For the specific scenario of 24 hot conductors and 8 neutral conductors feeding lighting and receptacles, and assuming that the lighting and receptacles do not create a significant amount of harmonic current, you would not need to count the neutral conductors towards the total number of current-carrying conductors. Therefore, you would only consider the 24 hot conductors for derating purposes. Looking at Table 310.15 Con, for 24 current-carrying conductors in a raceway, the derating factor is 60%. This means that you must multiply the ampacity of each conductor by 0.60 to determine its allowable ampacity in this installation. For example, if the conductors are number 12 American wire gauge THHN conductors, which typically have an ampacity of 30 amps at 30 degrees Celsius, after derating, their allowable ampacity would be 30 amps multiplied by 0.60, which equals 18 amps. This derated ampacity must be sufficient to carry the load served by the circuit. If the calculated load exceeds the derated ampacity, you would need to increase the size of the conductors or reduce the number of conductors in the conduit. Several factors can affect the ampacity of conductors, including the ambient temperature, the type of insulation, the size of the conductor, and the presence of other conductors. Ambient temperature is the temperature of the environment surrounding the conductor. Higher ambient temperatures reduce the ability of the conductor to dissipate heat, effectively lowering its ampacity. Table 310.15 Bone provides correction factors for ambient temperatures other than 30 degrees Celsius. Conductor insulation is another critical factor. Different types of insulation have different temperature ratings which determine the maximum temperature that the conductor can withstand without damage. Common insulation types include THHN, THHW, and XHHW, each with different temperature ratings and suitability for different applications. Conductor size is also a factor. Larger conductors have a greater surface area for heat dissipation and can therefore carry more current than smaller conductors. The National Electrical Code provides tables that list the ampacity of conductors based on their size and insulation type. It's important to note that the derating requirements of NEC 300 10.15 cone are cumulative. This means that if you have both ambient temperature correction and conductor derating due to the number of conductors, you must apply both factors to determine the final allowable ampacity. For example, if you have 24 current carrying conductors in a conduit and the ambient temperature is 40 degrees Celsius, you would need to apply both the derating factor from table 310.15 cone and the correction factor from table 310.15 bone. In practical application, calculating conductor derating involves several steps. Firstly, determine the ambient temperature at the location of the installation. This can be done using temperature sensors or by consulting local weather data. Secondly, determine the number of current carrying conductors in the raceway or cable. Remember to count neutral conductors only if they carry significant harmonic current or if they are part of a single-phase or three-wire circuit. Thirdly, consult table 310.15 cone to determine the derating factor based on the number of current carrying conductors. Fourthly, consult table 310.15 bone to determine the correction factor for ambient temperature. Fifthly, determine the ampacity of the conductor based on its size and insulation type. This information can be found in the NEC tables. Sixthly, multiply the conductor's ampacity by the derating factor and the correction factor to determine the allowable ampacity. Seventhly, ensure that the allowable ampacity is sufficient to carry out the loads served by the circuit. If not, increase the size of the conductors or reduce the number of conductors in the conduit. It's also important to consider the voltage drop in the circuit. Voltage drop is the reduction in voltage from the source to the load due to the impedance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, you can increase the size of the conductors or reduce the length of the circuit. The type of conduit used can also affect the ampacity of conductors. Different types of conduit have different thermal properties which can affect the ability of the conductors to dissipate heat. For example, metal conduits, such as steel and aluminum, are better at dissipating heat than non-metallic conduits such as PVC. Therefore, conductors in metal conduits may have a higher ampacity than conductors in non-metallic conduits. It is imperative to consult the National Electrical Code and follow all applicable regulations and guidelines when installing electrical wiring. Failure to do so can result in unsafe installations, equipment damage, and even electrical fires. The NEC is updated regularly to reflect changes in technology and best practices, so it's important to stay up to date on the latest requirements. In summary, when running 24 hot conductors and 8 neutral conductors in a 2-inch aluminum conduit to feed lighting and receptacles, you must derate the conductors according to NEC 300 10.15 cone. The neutral conductors do not count towards the total number of conductors for derating purposes, unless they carry significant harmonic current or are part of a single-phase or three-wire circuit. The derating factor for 24 current carrying conductors is 60%, which means that you must multiply the ampacity of each conductor by 0.60 to determine its allowable ampacity. This allowable ampacity must be sufficient to carry the load served by the circuit. Additionally, remember to consider ambient temperature correction and voltage drop when designing and installing electrical circuits. Always consult the National Electrical Code and follow all applicable regulations and guidelines to ensure safe and compliant installations. By adhering to these guidelines, you can ensure the safe and reliable operation of electrical systems.